All right, so we're looking at cosecant x, and we're trying to figure out what that graph looks like. We remind you that cosecant x is really the same as 1 over sine x. So the base graph starts kind of with the sine graph, which looks like this. All right, where this is 0, this is pi, this is 2 pi. And as we look at 1 over sine, what we get is asymptotes through pi, through 0, through 2 pi, and then we get these little mini parabolas. Look like this. That will run up and down the asymptotes. And so we have kind of a asymptote here, we have an asymptote here, and then we get these little mini parabolas, right? So that the red graph is the cosecant graph, the black graph is the sine graph. We're not really interested in the sine graph, so we just get rid of that part. Which unfortunately for me means I'm getting rid of the entire damn axis. Crisis averted. Okay. Now, what does this do to this picture? Okay, what does this do to this picture? Well, the plus pi over 4, I think hopefully we all realize that's going to shift it left pi over 4. But what is it going to shift? Is it going to shift the intercept or is it going to shift the asymptote? 0, 0 in this case is the asymptote. Do we agree? So let's shift the asymptote pi over 4. Okay, the asymptote will shift pi over 4. So now we have negative pi over 4, and that becomes an asymptote. Now, remembering that for the period of cosecant, the period of cosecant and secant are both 2 pi. So coming to the right 2 pi units, that will be my final endpoint where this thing would start again. Okay? That would be my final endpoint where this thing would start again. How far is that? From negative pi over 4 plus 2 pi, that is 7 pi over 4. Do we agree? Negative pi over 4 plus 2 pi is 7 pi over 4. Now, in the middle, there is an additional asymptote. Where does that asymptote occur? 7 pi over 4, negative pi over 4 is 6 pi over 4. 6 pi over 4 divided by 2 is 3 pi over 4. Okay. Does that make sense? Now, I did a very crappy job of spacing that out, so I'm just going to fix that. And we're going to put that right here somewhere. That's my y-axis. It occurred to me that my distance from the y-axis to negative pi over 4 was more than my distance from the y-axis to 3 pi over 4, and that's not good. Now, where is this hump going to be? That hump will be in the middle of these two values. So where is that at? That's 2 pi over 4. Cut it in half, you're at pi over 4. All right, so we're here at 1, and we have this little parabola going up like this. Coming here, we are at 5 pi over 4. We're at 5 pi over 4, which is in between 3 pi over 4 and 7 pi over 4 is 5 pi over 4. And that's this piece that looks like this. And we can continue that to the next side where it's going to go up, and continuing that to the next side where it will go down. Does that make sense? Okay. While I'm recording, for those of you that are watching at home, I would like to go ahead and remind you of the domain and range of all six trig functions. The domain is negative infinity to infinity. The range is negative 1 to 1. The domain for cosine is negative infinity to infinity. The range is negative 1 to 1. For tangent, the domain is all real except pi over 2 plus k pi. Remembering that the period for this is pi over 2 plus k pi. The range is negative infinity to infinity. The domain for cotangent is all real except for k pi. The range is negative infinity to infinity. For secant x, that's 1 over cosine. That has asymptotes at pi over 2 plus k pi. The range for that is negative infinity to negative 1, union 1 to infinity. And for cosecant, that's 1 over sine. That's all real except for k pi. And the range is negative infinity to negative 1, union 1 to infinity. Okay. Look, I mean, here's the bottom line. All 6 of those are going to be on the test. They're all in the non-calculator portion. I'm not telling you they might be. I'm not telling you they could be. I mean, it's on there. I promise you. All 6 are going to be on there. Not choose 4 of the 6. All 6. That's, in essence, 30 free points. That's the equivalent of 400 on the SAT. Do they still give you 400 points for putting your name on it? I mean, some of y'all going like this. I don't know. I got 600. Well, that's not good. Because they gave you 400 points for free. All right. Please, just know them. I mean, just force yourself to memorize them. Now, I want to ask you this question. Write the equation of the sine graph where the amplitude is 4 the period is 6 pi. It has a vertical shift up 2, and it has a phase shift right pi over 6. What would that equation look like? I'm going to press pause for those of you that are watching at home. You can press pause as well, and I'm going to get right back to you after these commercial breaks. Yes, this is on the test. All right. What does this look like? Well, it's a sine graph, so you know we're starting with y equals something sine. Do we agree? Now, which way is it shifted? It's up 2. It's shifted to the right pi over 6. Now, what's the amplitude? The amplitude is 4. It goes in front of the sine. Now, what's the period? It's 6 pi, right? So if the period is 6 pi, the original period is 2 pi divided by k, right? Well, what would k have to be?
1/3.
K would be equal to 2 pi divided by 6 pi, which is 1/3. So this is 1/3. And that's the equation.
Could you put the plus 2 at the end of the
You can put the plus at the end of the problem too.
Would it matter if you put the 1/3 inside the parentheses?
like a second set?
It would, if you put it like this, it's fine. If you just put 1/3 x minus pi over 6, that's wrong.
Because the 1/3 has to affect the pi.
The 1/3 would have to factor out, and then you end up getting pi over 2. Does that make sense? Let's ask this question. Y equals 2 tangent 3x minus pi over 2. What's the vertical shift? What's the phase shift? What's the amplitude? What's the period? I'll leave you to look at that. We'll press pause. What's the vertical shift?
Doesn't have one.
Vertical shift does not exist. Okay, not any. What's the phase shift? Say it again. No. It's pi over 6. Now, you can say either pi over 6 or you can say pi over 6 to the right. Either way. Does that make sense? All right. What's the amplitude? Does not exist. There is no amplitude for tangent and cotangent. It's a trick question. All right. I mean, I don't want to say it's a trick question. It's a trick if you don't know how to do it. All right. It's like going out and looking for a bucket of steam. You're not going to find one. I mean, if they give you a bucket and say, go get me a bucket of steam, you ain't going to do it. Can't happen. All right. All right. What's the period?
Pi over 3.
Period in this case is pi over 3. Okay. So these are other ways I can test. Do you understand shifts and periods and all that stuff? I can just ask you, what are they? I can give you an equation and say, you know, which way does it move? Which way does it go up and down? Which way does it go right and left? All right. I could tell you, look, give me a tangent that has these features. Does that make sense? Or I could just straight say, here, graph y equals 2 sine x minus pi over 4 plus 7. And then you graph it yourself.
Can you explain how you got the period?
Yes. So the question was, how did I get the period? And the answer is, the period for tangent and cotangent is pi normally. So if there's no number in front of the x, the period will be pi. If there's a number in front of the x, the period becomes pi divided by whatever that number is. If it's a fraction, you got to deal with the complex fraction. The phase shift is found by factoring out the 3, and you'll get x minus, well, if you factor out the 3, you got pi over 2 divided by 3, which is pi over 6. So that's a phase shift, pi over 6 to the right.
So what if the 3 was on the outside, I guess?
If the 3 were on the outside already, the phase shift would be pi over 2.
And then the period would be pi over 3 still.
Period would still be pi over 3, yes. Any questions on that?